In this lesson, we're going back to simplifying radicals. So when we get to the equations of solving by square root method and quadratic formula, that we are focusing on that simplifying portion. So there are a couple of ways that you could simplify radicals. So like, for example, you could do prime factorization. So what I mean by that is the square root of 45, for example, right? I could take the square root of 45 and break that down into two factors. So for example, 9 and 5. Now, 5 is a prime number. It has no other factors besides 1 in itself, so we're done. But 9 can be broken down to 3 and 3. So I broke 9 down to 3 and 3, which are both prime. So notice there's nothing else to break down because we have nothing but prime numbers. Then you take out your pairs. So notice how here you end up with 3 radical 5. So one option is to do prime factorization. What I'll be focusing on in this video is identifying your perfect square factors. So perfect squares, like 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 9, 4 times 4, 16, 5 times 5, 25, right? 6 times 6, 36, 7 times 7, 49, 64, 81, 100, right? Could definitely keep going because that's 10 times 10. 11 times 11, 121, 12 times 12. I'll stop here since I'm running out of space. So notice how these are the perfect squares for 1 through 12. And again, you don't memorize this. You can just multiply the number to itself if you're looking to see what those perfect square factors are. So we're using these as our factors to identify which of these is a factor of 45. Well, again, starting highest, well, the factor of square root of 45 is 9. So I can break this down into the square root of 9 times the square root of 5. Square root of 9 times square root of 5, square root of 45. So now notice my perfect square factor, or perfect square here. What is the square root of 9? 3. Bring down the radical. 3 radical 5. So here I'll focus on those looking for that perfect square factor. So like 72, right? Start off larger because 9 is a factor of 72, but there's a larger. So that's why I would suggest, again, start up high, like 49. 72 divided by 49. Is 49 a factor? No. When you divide, you'll get a decimal, right? 36. Is 36 a factor? 72 divided by 36. Yes, because what is 72 divided by 36? 2. Here we go. What is the square root of 36? 6. Bring down radical 2. That is radical 72 simplified, 6 radical 2. So we'll do this one, radical 28, right? Start large and work your way down. Which of these is a factor of 28? Is 9, 28 divided by 9? No, that's going to give you a decimal. So 28 divided by 4? Yes, because what is 28 divided by 4? 7. So now we simplify, right? What is the square root of 4? 2. Bring down the radical. 2 radical 7. Go ahead and pause the video and try 147 on your own. And here we go. So again, notice how 147, if you were to figure out factors, right? So you could start dividing. 147 divided by 81. Nope, not a factor. 147 divided by 64. Nope, not a factor. 147 divided by 49. Yes, when you divide it, 147 by 49, you get 3. So 49 times 3 is 147. So now here we go. What is the square root of 49? 7. Bring down your radical. 7 radical 3 is the square root of 147 simplified. So now in our next examples, these are here just so that you guys can see if we ever had like adding and subtracting radicals. So again, we're going to simplify. Radical 75. Well, radical 75, which of these is a factor of radical 75? 25. Radical 25 times radical 3. So now what is the square root of 25? 5. So 5 radical 3. We're going to add to that, simplifying radical 48. So perfect square factor, if you were to go down, yes, 4 is a factor, but again, focus on going larger, right? 36 is not, 25 is not, but is 16. Yes. 48 divided by 16 is 3. So radical 48 can be broken down. Radical 16 and radical 3. Now what is radical 16? 4. Bring down the radical. So now notice when adding, and then we're going to just kind of keep this concept in mind, adding and subtracting. We'll add these values here because it's like we have like terms. See how we have the two radical 3's? So we can add 5 plus 4. 5 plus 4 is 9, but do not add the radicals. See how here we have our radical 3? You leave it, radical 3. So keep the radical out of that situation here when we are combining, because this is a completely different type of term. So keep that in mind when adding, subtracting, and then you'll even see it too when we get to our dividing. So here, radical 32, breaking it down into what, two factors? Well, 25 is definitely too big. What about 16? Yes, because when you divide, you get 2. So radical 16 is 4. So 4 radical 2. Then took care of that. So minus radical 18. So how can we break this down? Which of these is our factor? 9. Radical 9 times radical 2. So the square root of 9 is 3. So 3, bring down radical 2. Now we can subtract because notice how we have the two radicals. 4 minus 3 is 1. So just 1 or just radical 2. So go ahead and pause the video and do these two on your own. And here we go. So for radical 20, you should have broken this down into radical 4 times radical 5, because radical 4 here is 2. So 2 radical 5 plus, you should have seen that you could break down 180 into radical 36 and radical 5. So then here, radical 36 is 6. So 6 radical 5. So then when you combine, because they both have the same radical, you get 8 from 2 plus 6. 8 radical 5. Don't add the radicals, you leave it. Then the last one, radical 128. So here, you should have broken this down into radical 64 times radical 2. So then here, the radical 64 is 8. Bring down radical 2 minus, then break down radical 98 into 49 and 2, because radical 49 is 7. So 7 radical 2. So when you subtract, you end up with 8 minus 7, which is 1, or just radical 2. And so now in these examples, notice how we're still simplifying, but we're now dividing. So again, you can see our rules with our radicals when we're simplifying. So we're going to build on this. So radical 200, breaking that down. So radical 200 can be broken down into which of these perfect square factors? 100. So radical 100 times radical 2. So here we've got radical 100, which is 10. So 10 radical 2. So here we go. We've got 10 radical 2 being divided by 5. So now notice, leave the radical, just like what we did with adding and subtracting. Divide 10 by 5. 10 divided by 5 is 2. 2 radical 2. That is your simplified form. So let's do the next one. So like with 192. So if we were to divide, so let's simplify here, radical 192. So which of these is a perfect square factor of 192? So start dividing out so that you can see 64. Like let's say, for example, you thought 81. Well, then try it out. 192 divided by 81 will get you a decimal. So then go to 64. Well, what's 192 divided by 64? 3. So now what is radical 64? 8. So 8 radical 3. So here we go. I've got 8 radical 3 being divided by 2. So now notice I can divide. 8 divided by 2, which is 4. So 4 radical 3. Go ahead and pause the video and do these two on your own. And here we go. So with radical 243, you should have broken this down into 81, 81, and radical 3. So here, radical 81 is 9. So 9 radical 3. So we're going to divide 9 radical 3 by 3. Now again, you only focus on these values here. You leave the radical alone. 9 divided by 3 is 3. So 3 radical 3. Don't divide the radical. You leave the radical alone. So 3 radical 3. So then the last one, radical 245. So here, when you broke this down, you should have seen that this is a factor of 49. So 49 and 5. So here, radical 49 is 7. So 7 radical 5. So you simplify 7 radical 5 over 4. Now you should have noticed, can we divide? No. So that is your simplified form. You just leave it. So then the last, leading up to our portion here. Notice how this is like the setup of the quadratic formula. And so just practicing this when we get to our quadratic formula, notice how the radical 50, well, can we simplify radical 50? Yes, because it has a perfect square factor of what? 25. So radical 25 and radical 2. So now here I've got radical 25, which is 5. So 5 radical 2. So let's rewrite it. We've got 10 plus or minus 5 radical 2 over 5. So now notice to simplify. I can divide both 10 by 5 and 5 by 5. So it's like two separate division, like when we were doing GCF. 10 divided by 5 is 2 plus or minus 5 divided by 5 is 1, kind of like canceling out. And so you're left with 1 or just radical 2. That is the simplified form. So here, radical 12. Can we simplify radical 12? Yes, because it has a perfect square factor of 4. So radical 4 times radical 3. And then what is the square root of 4? 2. So 2 radical 3. So again, let's go back. Here we go. So 6 plus or minus 2 radical 3 over 2. Now, can we simplify? Yes. 6 divided by 2 and 2 divided by 2. 6 divided by 2 is 3 plus or minus 2 divided by 2 is 1. So just 1 radical 3 or radical 3. So go ahead and pause the video and try the next two on your own. And here we go. So with radical 108, you could simplify that to 36 and 3. So now the radical 36, square root of 36 is 6. So 6 radical 3. So now let's go back to simplifying. 9 plus or minus 6 radical 3 over 3. So here we go. you should see that you can simplify dividing 9 by 3, 9 by 3, and 6 by 3. Because remember, right, leave the radical. 9 divided by 3 is 3, plus or minus. 6 divided by 3 is 2, radical 3. So then the last, radical 320. So you should have seen that radical 320 can be simplified to 8 radical 5 because of the square root of 64. So 12 plus or minus 8 radical 5 over 4. So now we can simplify. Divide 12 by 4 and 8 by 4. 12 divided by 4 is 3 plus or minus. 8 divided by 4 is 2 and radical 5. So that is your simplified. So again, why are we doing this? Going back to now solving our square root, solving by square root method problems. Because see how we just have the two terms, no x term. So you can solve using square root method. We're solving for x here, right? We're adding 5, so we would subtract 5. Then 2x squared is equal to 100. Now we're still multiplying x by 2, divide by 2. X squared is now equal to 50. Then what can we do? Take the square root. So now we can simplify. Can we simplify radical 50? Yes, into 25 and 2. Because what is the square root of 25? 5. Now, because we're solving for x, we've got this equation here for x squared. We're now going to use both the positive and negative. So positive, negative, 5 radical 2 from the square root of 25. All right. So again, now it's back to why did we do all of this, right? So here we go. What are we going to do first here to solve for x? Add 28. So add 28. And now here you end up with 4x squared is now equal to 108. So now what are we going to do with that 108? We're going to take 108 and divide by 4 because x is being multiplied by 4, right? So divide by 4, x squared is equal to 27. So now what can we do? Take the square root. So now here, simplify radical 27 into what perfect square factor? You need to go back 9 and 3. Because what is radical 9? Square root of 9 is 3. So 3 radical 3. So x is equal to plus or minus 3 radical 3. So go ahead and pause the video now and do these two U-tries on your own. And here we go. So you should have noticed solving for x here, right? We're adding 19, so subtract 19 from both sides. 5x squared is equal to 40. Now what do? Well, x is being multiplied by 5, so divide by 5. X squared is equal to 8. So now notice we got x squared, take the square root. So now x is equal to, simplify radical 8 because it does have a perfect square factor of 4, 4 and 2. Because now what is radical 4? Square root of 4 is 2. So that's why here you end up with plus or minus 2 radical 2. And so here, last one, you were subtracting 36, so you're to add 36 to both sides, solving for x here. Now I've got 3x squared is equal to 120. And we're still solving, we're multiplying by 3, so do the opposite, divide by 3. X squared is equal to 40. Now, last step, take the square root. But let's see, can we simplify radical 40? Does it have a perfect square factor? Yes, of 4. Radical 4 and radical 10. So what is radical 4? Square root of 4 is 2. So 2 radical 10. So that's why x is equal to plus or minus 2 radical 10.